And related to the calculus, we have done the questions related to the work done by a force or a vector point function. So a few questions were explained in the previous class, and we shall continue with the same. So find out the work done. This is another example we have. Find out the work done when a force, the force vector F is given to us x square minus y square plus x into I cap minus 2xy plus y into j cap moves a particle in the xy plane from the point P 0 to the point Q 1 along the parabola, and the parabola is y square is equal to x. And if you remember, the parabola is y square is equal to x, and we know that y square is equal to x is a right-handed parabola. So this is the point P with coordinates 0, and suppose this is the point Q with the coordinates 1, and the particle is moving along this direction P to Q with the force vector F. You have to find out the work done. Now, this is the first part of the question, and the second part of the question is find out the work done when the particle is moving along the curve y equal to x. This will be the second part of the question, and they are saying that is the work done different when the path is this straight line y equal to x. And you know that what is this? This is the straight line y equal to x. If you will be able to find out the equation, so draw a straight line joining the point P. Sorry, we have to draw a straight line joining the point P to Q. This is the straight line we have, and they are saying that is the work done different in case 2 than in case 1. So let us check whether the work done is different or not. Now you know that a parabola is a 2D figure, so we shall have a position vector r in 2D plane with the vector point function xi plus yz, and you also know that dr will be dxi plus dyg. Now you can find out f dot dr, and that will be x square minus y square plus x into dx, and there should be negative sign. So negative 2xy plus y into dy. This will be your f dot dr now. And now what we need to do, we need to put the values of dx and dy, or one of the value. So how will you find out the value? From this. Finding out the derivative of this parabola equation, you will get 2y dy is equal to dx. So you can substitute the value of dx as x square minus y square. Okay. So if you substitute the value of dx as this, you will also substitute the value of x as y square. So x square means y square whole square. So this is y4 minus y square plus y square into dx. Dx is 2y dy minus 2x y. That come out to 2y cube plus y and dy as it is. So this is cancelled. So this come out to 2y5 minus 2y cube minus y dy. This is your f dot dr. Now you can find out the required work done. You know that for finding out the required work done, you need to take the integral of this and dot product f dot dr and within the limits because you are moving along the curve parabola because we have used the equation parabola here. So this is the parabola we have and this is the straight line we have y equal to x. So during with the parabola the limits of y, the limits of y are 0 to 1. So you will substitute the limits. Now within the limits of 0 to 1, 2 by 5, 2 by cube minus y dy. So you can integrate it, which is 2 by 6.6, 2 by 4 upon 4 minus y square upon 2. Within the limits 0 to 1. Now you can substitute the upper limit and you will get 1 by 3 minus 1 by 3 minus 1 by 2. So this will be your, this should be 1 by 2. And now this will be your value and you can take the LCM, this is 6, sum of 2 minus 3 minus 3, that will be minus 4 by 6 and that will be minus 2 by 3. So this is the work done. And you just see, we are getting the work done in a negative value. But the work done should always be a positive quantity. Why it come out to be negative? Because we are using the clockwise direction. That's why the value come out to be negative. So you can omit the negative sign also and get the value. That is 2 by 3. Now, this is the case we have second one. Let us check whether the value in case number 2 come out to be same or not. So this come out to be dy equal to dx. So required work done will be within the limits. Again, the limits of either of x or y are same, 0 to 1, 0 to 1. Let us change the variable in this equation. Put the value of y equal to x. So x square minus x square plus x into dx minus that will be 2x square plus x into dx. So this is cancelled and ultimately what we have 0 to 1 minus 2x square dx, because this x will also be cancelled with this and dx can be taken common. So ultimately what we have minus 2x cubed over 3. So we are getting the same value. So it means the work done in both the cases, case number 1 when we have a parabola, case number 2 when we have a straight line, will always be same. So this was the question. We may change the statement of the question in many other ways. They can change the question and suppose they give the curve is x square is equal to 2y, then you have to do accordingly. Suppose they change the question that they give you the curve like x is equal to 2y square, so then you have to do accordingly. So there may be many kind of questions by using the same vector point function and you have to do the question accordingly. So you must practice for these parts also at home, part number 3 and part number 4 or any other part which comes in your mind. You must practice these questions. Now, we have another question, and the question is of they are saying that compute integral along C f dot dr, and what is given to us, the vector f is given to us by I cap minus x g cap upon x square plus y square. This is given to us, and you know that vector R is always a standard xi plus yj. And what is the C? Where C is the circle. The equation of circle is given. And transverse counterclockwise. So it is given to us that it is in counterclockwise direction. So you can take f dot dr. It is clear that f dot dr will be y dx minus x dy divided by x square plus y square. And for the equation of circle, we can use the parametric equation x equal to cos t, y equal to sin t, because the radius is 1. So we will get that, we will get the value, and the value is, because this is the equation of a circle, and in the uh, when you substitute the value of y is sine t, and dx will be minus sine t into dt, minus the value of x is cos t, and dy is cos t dt, and it is divisible by 1, because x square plus y square is 1. And when you substitute the value, you will also get 1. So ultimately what we have, minus is common, sine square t plus cos square t into dt. And this value is also 1. So this is integration minus of dt. Now the question arises, the circle is given to us, where C is the circle in counterclockwise direction. So in counterclockwise direction meaning we have this circle, plot a circle. This is x-axis and this is the y-axis. This is the circle with the radius 1 and the center at origin. So this is the clockwise direction, and this should be the counterclockwise direction, moving on this side. So when we move on this side, the circle is taken as counterclockwise direction, and the limits come out to be at the point 2 pi to 0, because this is the point we have. So wait a minute.
हेलो सर, आवाज़ नहीं आ रही सर। सर आवाज़ नहीं आ रही सर।
देखिए, हाँ बेटे अब ठीक है।
हाँ जी सर, अब आ रहा है।
आ रही है ना?
हाँ जी सर।
Okay. So we have given the upper half of this circle, and the points are given that we are moving from A to point B, and this is the point B we have, and this is -1 and this is +1. And you know that in the semicircle we shall always move in counterclockwise, in anti-clockwise direction. And you know that we want to find out the work done. So for finding out the work done, we have to find out the circulation. Circulation around the curve C. And what is the curve C? The curve C is from the point A to O, then O to B, then B to A. So this is the total curve C, which is a semicircle. And you can substitute the value, and this is also a closed curve. Minus y dx plus x dy over x square plus y square. And this is the semicircle given to us. And you know that the Cartesian equation of the semicircle are put x equal to cos t and y equal to sin t. So what it will be? That will be minus sin t into minus sin t dt, derivative of x. So dx will be minus sin t dt, like x is cos of t into cos of t dt. And in the denominator, that will be cos square plus sin square, that is 1. And what is that? Because we have a semicircle, for the complete circle, the limits are 0 to 2 pi. But for the semicircle, the limits are 0 to pi. This is the important difference here. So it come out to be sin square t plus cos square t into dt. So it is also 1. So ultimately you will get a pi in this case. And this is the question of a semicircle. So in the case of a semicircle, the revolution is half, just like this. On the straight line, we move from this point to this point. This is the semicircle. But when we move from this point to again the initial point, this completes a circle. And we should see the difference. In the previous question, we are getting the final value as a 2 pi. Previously, this was your 2 pi because the complete circle has been given. But now in this case, it is a semicircle, and semicircle represents 180. So the answer comes out to be pi only. So this was your important questions of a line integral or a work done. Single integral, I have just told to you yesterday that single integral denotes line integral. Line integral means integration around the curve, whether the curve is a straight line or a circle or a parabola. So that is why it is said to be a line integral. But now, today, we shall do the questions related to surface integral. Surface integral means in 2D plane. So, in 2D plane, we should always have a surface. So, this is another important part in vector point function. This is very important, surface integral. And for the surface integral, we should have to evaluate double integral vector f dot n cap dx. S stands for surface. So this is the integral over S. N cap is the unit vector which is normal to the surface. So this is the surface suppose we have, and the name of the surface is S, and n cap is a unit vector along the normal to this. So this should be n cap. This is any point P, and at P, a normal vector has been taken to the surface. So this is said to be the surface integral, and there is the procedure to find out ds. This is the procedure that ds will be dx dy if the surface is lying in xy plane. So what it should be dx dy, and in the denominator you will take the dot product of k cap with n cap. Just see, in xy plane we always have I cap, j cap, and you will take the third vector, that is along z plane or along z axis, that is k cap. But if we have in yz plane, then it should be dy dz, and in the denominator it should be I cap dot n cap. N cap is a standard vector which is normal to the surface. And similarly, we shall have one more case that can be in xz plane, and in xz plane in the denominator we should have j cap dot n cap. In the denominator we always have dot product, and we will take the absolute value of that dot product. This is another important point which we shall use in finding out the value of surface integral. So let us do a question. It is a very important question of surface integral. Evaluate the surface integral. That is why it is a double integral over the surface S, and the vector F is given to us 18z I cap minus 12j cap plus 3y k cap. This is the vector F, and S is the surface of the plane. The plane is given to us 2x plus 3y plus 6z minus 12 is equal to 0 in the first octant. Important point to note, in the first octant. In the first octant, we should have a positive values. Always remember that in the first octant, we should always have a positive values. So we shall take the double integral in xy plane, and it means your ds. ds we need to take like that. That will be dx dy, and that will be k cap dot n cap. We shall take, because we are in first option. And how to find out n cap? N cap is always be the gradient of this vector 2x plus 3y plus 6z minus 12. Gradient of this surface divided by its magnitude. So you just need to find out the magnitude of this value. So you can write down, that is 2x plus 3y plus 6z minus 12 gradient its magnitude. Because for unit vector, we should always divide with its magnitude. And let us find that. That is 2I cap plus 3j cap plus 6k cap. Derivative with respect to x into I cap. Derivative with respect to y into j cap. Derivative with respect to z into k cap. This is the procedure to find out gradient. Divide by its magnitude. 2 square plus 3 square plus 6 square. What it should be? That will be 36 and 9, 45 plus 4, 49. So 1 by 7, 2I, 2j plus 6k. So this is your n cap, unit vector normal to this surface. So now let us find out the dot product of F with n cap. This is n cap, F is there. So you just find out the dot product now. And F dot n cap come out to be. Straight away put the value here. just put the value here. That will be double integral f dot n cap, that is 18z I cap into this. So 18z into 2 by 7 minus 12 into 3 by 7 plus 3y into 6 by 7. And what should be df? df is dx dy divided by k cap dot n cap. We find here k cap dot n cap separately. So here we will find out k cap dot n cap. So k cap dot n cap will come out to be 6 by 10. So you will write down that is 6 by 7 because it is the positive value. So ultimately what we have clearly 7 has been cancelled out with this 7 coming. So 1 by 6 is there, that is 36 z minus 36 plus 18y into dx dy. And one more question comes here, that we are in xy plane, so we should substitute the value of z. So how to find out the value of z from this equation of plane? So from this equation of plane, we can substitute the value of z. That will be calculated as 12 minus 2x minus 3y upon 6 from here. Equation of plane minus 36 plus 13y into dx dy. Now, as you know, we are in the positive option as it was given in the question. Positive option means in xy plane, and in xy plane we should always use the positive limits of x and y. So from this equation of plane 2x plus 3y plus 6z minus 12 is equal to 0, you will find out the limits. And because in xy plane we are doing, so you will take this as 0. So ultimately the plane will be in 2D. So this will be your plane. And now you will take one limit in the angle. So what we have, this is 1 by 6 double integral. You can simplify it a little. So what is come out to be 18 can be taken common. 18 is common over here. So this will be 2 by 2 is there, that should be 3. 12 minus 2x minus 3y over 3 minus 2 plus y. This is left with that dx dy. This can also be common. 3 double integral. You can take the LCM. 12 minus 2x minus 3y minus 6 plus 3y over 3 dx dy. 3y is also cancelled, and the 3 can be cancelled with this 3. This can be cancelled. So ultimately what we have, that will be 12 minus 2x minus 6. Now 2 can also be taken from, that is 6 minus x. 12 minus 6 is 6. So ultimately what you have, 3 minus 6 is left with us. So this is left with us, 3 minus 6. Now you need to find out the limit because we are in xy plane. So what do? You find out x. Find out x, you should have 12 minus 3y. So x come out to be 6, and that will be 6 minus 3 by 3y. So the limits of x are 0 to 6 minus 3 by 2y. And, for finding out the limits of y, you will not take the value of x. You will take only the value of y with the constant. This is the procedure to find out the limit. So y, 3y equal to 12, y come out to be 4, and that will be 0 to 4. Why we are taking the lower limit as 0? Because we are in first option. In first option, the lower limit will always start from 0 because we are in positive option. Now you can integrate it. So first, the limits of x are in y. So whether we are taking the limits of one variable in another variable, then you will integrate with that variable first. So we are taking the limits of x and y. So you will integrate with respect to x first. So that is 3x minus x square upon 2. 0 to 6 minus 3 by 2 y into 2. Now substitute the limits and what is this? That will be 2, 0 to 4. Put the value of x. And we substitute the value of x. 6 minus 3 by 2y minus 6 minus 3 by 2y whole square upon 2 into dy. Simplify it 0 to 4, and this come out to be 18 minus 9 upon 2 into y, and here we will have 36 upon 2, 18, and that will be 9 upon 4 into 8, that will be minus 9 upon 8 into y square. And next value should be negative. Negative means to become positive, and that will be 6 3 18 y upon 2. So you will have this value after taking the square. So what we should have, 18 is cancelled, and this come out to be 9y, and 9 is common from all, and that will be 0 to 4, and that will be y minus y by 2, and that will be minus y square upon 8. So this is left with us, and after solving this also you will get y by 2 minus y square upon 8 integration using the limit 0 to 2. So you will integrate it now, and what it come out to be 18 y square upon 4 minus y cube upon 24. The limits are 0 to 4. So substitute the limit. Upper limit will give value only. So 4 square is 16. 16 upon 4 is 4. Minus 4, 4 was 16. 16 4 was 64 upon 24. So this will be the value here. You can cancel 4, putting that, sorry, that will be 4, 6, that will be 16, 4, 3, and that will be 8. So ultimately it is 4 3 is 12 minus 8, 4 by 6. So that will be 24. 24 is the final value which you will get after applying the surface integral. So this is the procedure to evaluate the surface integral. You just see, you have to start the question, then apply the rules of integration one by one. But remember, it is a question of double integration. So you have to apply double integral, and in double integral, one limits will be in form of variable, another variable, and another variable will be in terms of constant. Now the question may come also, because this is the equation in xy, because we are in xy plane. That is why we are taking, and we will take z as 0. So you will not take the value of the term involving z in this case of plane. So either you find x in y or you find y in x. So one you find in terms of another, and another variable will be in terms of a constant. So thank you very much. This is about the surface integral, and we shall continue with the same in the next class.